So there's the expected value. I've changed that. Now they ask me for variance, right? So just like before, instead of working out the variance of 2x minus 4, change all the data and then calculate it, I'm just working out the variance as it is and then doing whatever change is necessary. We'll look at that in a second. Okay? So variance, again, I'm multiplying probability each time. And then, okay, take your breath. It's the value, subtract the expected value, then square. Right? So there's my first value. Subtract my expected value, and then square. This, by the way, is a perfect example of when you save that value, save it into your calculator, so you don't have to write 2.85, do it 5 times. Pop it into one of the variables that you've got there, and then you'll get it. Okay, I'm going to finish writing it first, and then we'll get a value for you. So you do need to have that working there. It's important. There's that one. Probability, value, take away, expected value, square. Probability, value, take away, expected value, and then square. Last one. Probability, value, take away, expected value, and then square. Whew. That's why we were doing this with spreadsheets. Serene, did you say you already had a number on this one?
No, I just had one of the first ones.
Oh, that's okay, no problem. Someone can let me know once they've finished writing and calculating what they get. Did you get something?
Oh, nice.
Yeah, do calculate it. That's, you know, we need practice doing that. We want to make sure we get it right. I have a value. I just want to make sure that it agrees with your one. Bless you. You got something, John?
No,
Oh, you're not sure?
that thing again where you say
Which thing? Oh, yeah. Okay, so what did we say? 2.85? That's the thing we want to say. So assume you've done your calculation and then it's there.
Yeah.
You go shift, store is right there, and then you pick a letter. The A will do.
Yep.
So just tap on that. And any time you use alpha A, it'll do that. So for example, I would write this as 0.2 times 1 take away alpha A.
Okay.
And then you don't have to write 2.85 every time. Okay,
So
easy. What'd you get?
1.627.
Cool. What'd you get? Yep, excellent. 1.6.
627.
Okay, fantastic. We've got a bit of agreement here. Anyone else? Will, Sophie, you guys? Yep, Kira. Eventually we will get there, okay? Now we have the variance for the data as it was first presented to us, but now they're asking a slightly different question. What is the variance if we change the scale, 2x, and then change the origin, take away 4? Okay, come back to your table that we wrote down before. Here it is, right? Here's variance, okay? Let's start with this one. Change of origin, does that have any impact on the variance? And the answer is no, because if you move all your data together, it's still just as spread out as it was before, or not spread out as it was before. So I'm going to kind of ignore this takeaway 4. Is that all right? I don't need to worry about it. But that too, the change of scale, what effect does that have? It's going to make my variance 4 times bigger, 2 squared times bigger, okay? And in fact, I encourage you to write it exactly like that. It's going to be 2 squared, don't go straight to the 4, because this shows you know where the 4 came from. 2 squared times the original variance, like so. So whatever this number is, I'm going to multiply that by 4. Say again. Okay, so what I've done is, I'm thinking about variance now for not the original data, as it was on the page, but now I'm thinking about, well, what happens if I change the scale of the data, make everything twice as big, and also change the origin, so move everything downwards, okay? I noticed that, you know, when you change the origin, it doesn't affect the variance at all. When you change the scale, it does. It changes it by the square of whatever you're changing by, right? So I'm changing it by double, so I'm going to double squared. Has someone got the answer for me already? Is it a 5 point something? 4 times that? No, 6 point, what is it? What? 6.51? There we go. So there's our new variance, okay? Now, what I'd love you to do is, that's 23. I'd love you to try without quite so much help over the page. See if this wakes up. Tick, 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 tick. Success. Okay, so this is just over the page. Okay. Now, you can see this stuff down here is exactly what we were thinking about before. But let me remind you how to do these earlier bits, right? Express m in terms of n. Where are m and n on this set of data? It's here underneath the 2 and underneath the 4. So these are probabilities, right? This is a discrete random variable. So what do you know about all the probabilities? They add up to 1. Very good. So when you write that, this plus this equals 1, you'll be able to do part A. Okay. For part B, it says given that the expected value of this data set, not this one, this is x. I'm thinking about x squared. Given that it's this, then solve for the value of n. So what you need to do is take all of your, oh, I left my pencil down on the, let's do it this way. Sorry, this is messy. We're now thinking about the expected value not of this, but of x squared. So when you go ahead and do the calculation, you're not going to put in 1, you're going to put in 1 squared. You're not going to put in 2, you're going to put in 2 squared, and 3 squared, and 4 squared, and so on. Go ahead and work out your expected value, but you know what the answer is supposed to be, right? So you can use that to then calculate n, and then calculate m. See how far you can get with that nudge in the right direction. We're about to hit the bell, but I would really love, while this is still fresh in your brain, we'll take a bit of a break later, but try and get this down now. Turn over the page if you haven't already, and see if you can do 24 in your book. Okay, off you go.